We'll wrap up our discussion on testing with dependencies in this part of the presentation. We looked at an example of writing tests with dependencies. We'd learned a few number of principles and practices along the way. Let's reiterate some of those and also cover a few other grounds that we haven't really gotten a chance to cover with that example. First of all, the question is, when do we mock and when do we not mock? Should we mock or should we not mock? Well, the question really should boil down to what's the real purpose of mocking? The purpose of mocking is to really make the test easier to write and faster to run. If we are already able to write the test easily and run them fast without mocks, don't bother writing mocks. I mentioned this earlier. I use mocks very reluctantly. I use mocks as an exception than a norm. I will try my best to really remove dependencies, reorganize code, and make sure I don't have to really deal with the dependency if I can get away with it. For example, if you tell me, could you get me enough water to fill up this bottle? My question is, what kind of bottle is it? What is the shape of the bottle? Do you want up to the brim? Are there going to be other things I need to be concerned with? Instead, if you say, could you please get me 8 ounces or 250 milliliters of water, whatever the dimension is, I don't care about the container, I care about the volume, 16 ounces, 8 inches, 250 ml, 500 ml, whatever that is. So the point is, focus on really removing dependencies and focus on the logic where you can. The less dependency you have, the less mocks you really need. So use mocks as an exception than a norm. If you have a lot of mocks in your application, that's a sign of poor design. You want to have the least amount of mocks to get away with. Also, from the point of view of developing application, develop it with the testability in mind. See if you can provide fake services that can stand in and provide responses so that you can quickly run your tests with fake data and fake services. So should you mock or should you not mock? Well, only mock if the mocks will make your test faster. If you have a class, it is very easy to set up. It is very predictable. You can easily work with it. Don't bother mocking. Say, for example, you're writing a piece of code that does some engineering calculations. It has to talk to a pure class that does unit of measure conversion. You give it data in metric unit, it gives you data in English unit. You give data in English unit, it gives you data in metric unit. It doesn't depend on any external resources, let's say. There's no reason to mock that. Simply write your code that talks to the object, be done with it. You are quite fast at using this code. No reason to really spending time mocking. So don't mock code that is fast. Don't mock code that's predictable. Don't mock code that is easy to work with. Don't mock out code that you can easily set up. So any dependency that doesn't bother you, don't bother mocking. Mock if things are slow, things are unpredictable, or a service works properly most of the time, but you want to make sure your code is misbehaving or working correctly when the service misbehaves. Well, if the service doesn't misbehave, how do you make sure your code is dealing with any potential errors? That's a good time for mocking, only for the ill behavior, and you could directly use a service for good behavior. So simulate the ill behavior through your mocks and make sure your code is misbehaving or working properly and ensure that it is doing the right things. So mock when the code is unpredictable, slow, or you want to test for various different failure situations that may not be easy to set up on the real object, set them up using mock objects. What do you mock? So mock code that you are dependent on directly, and only if, as we talked about, if it's going to help you by speeding up your test and making your test more reliable and predictable. When do you not mock? Do not mock multiple levels below. For example, if you consider this case where you have this object, you are testing this object, there is absolutely no reason for us to mock the one on the right extreme. This right extreme object doesn't deserve any mocking when we are testing the leftmost object. In fact, you don't even mock these two objects. It directly depends on when you are testing the object on the left. And the reason for it is, remember, in a particular test, very thin slice of operation should be happening. So if your test is granular enough, that test may not depend on any dependency. Second, that test may only require one object or the other, not both of them. So if you are figuring that you need to mark out a lot of stuff at the same time, it usually is a sign that you have not separated things properly in your code, and you can do fairly good amount of separation and reduce the amount of marks you would actually need. Well, what about databases? What if I have code that talks to databases? Well, clearly, if I insert a data into the database and come back and rerun my test would fail because I may have a conflict of key or uniqueness constraint violation. Or I may expect a data to be present in a certain way. A test runs, modifies the data. The test comes back. Oh, wait, the data is not in the same shape anymore. What do I do? Well, the wrong approach to this would be to set up the database, clear it out at the end of the test, and recreate it. And this also leads to problems when you alter the sequence of tests. Things may begin to break. So what's a better answer when it comes to databases? The first answer is, if you can, let's say this is the level that is talking to the database, and if you're really testing this code, don't worry about the database. Mark out the code you directly depend on, and you don't even get that far into the database to start marking. That's one approach. So mark away the code you directly depend on so you don't have to worry about the database. Alternately, one of my favorites is to set the database in a rollback only mode. So you initialize the database with pristine data, and then how do you do this? Well, there are tools for this. Ruby on Rails has migrations built into it. There are tools like DB Liquibase, DB Deploy, for example. So DB Deploy, Liquibase are examples of tools that you write code in, like XML format, for example. And anytime you modify the data in the XML, it'll repopulate the database, not otherwise. So the database is in a pristine state at all time when you start your test. And you never have to recreate your database if all you're doing is running the test over and over, because you run your test in a rollback only mode. So when you run your test in rollback only mode, the code wakes up. You got to design the test properly for this. It pulls the data, does something with it, modifies it, saves the data, but the commit is not allowed. It is simply going to roll back at the very end. So since your test is in the same transaction, it sees the change, but once the test is complete, the data is discarded, the database is left in a pristine state. So you can run tests in any order, any number of times, and you don't have to worry about brittlety of your tests. So I would rather run the data with all the full-blown examples and run them quickly if I can, as long as it doesn't turn into a maintenance nightmare. If I design it properly, I should be able to do this fairly well. Also remember, don't create one mock object per class. Instead, create a very small, teeny-mini mock object per dependency, per usage in a test. So every single test may optionally have a mock, but that mock will be there only to serve that test purposes. So don't create a grandiose, full-blown mock object. Instead, create very little small objects that serve the purpose of the code interaction for just that test to pass. One last thing I want to emphasize is, if you can avoid creating mocks at any cost, avoid creating mocks. If you can postpone or move around so that you can create fewer mocks, that's better. I was working on a piece of code about 2 weeks ago, and I was creating mock objects. Within a few minutes, I realized that I don't really have to work that hard. Got rid of the mock, redesigned the code, removed the dependency from that location, moved it upstream. I didn't have to really mock at that level at all. So a lot of these things can save us a lot of time and effort. I was speaking at the Software Design and Testing Conference one year, and the topic was around whether unit testing is really possible with the brittlety that is introduced by mock objects, and people are talking about how they suffer with TDD because of mock objects. Well, after listening for a few minutes, I blurted out saying, hey, maybe you're having trouble with your TDD because your design sucks. With that, I made everybody in the room really angry. They said, who are you? Why would you say our design sucks? I said, I write a lot of code where my design sucks. I thought you guys do the same thing too. And then we started discussing the examples, and we brought out an example, and we talked about this, and essentially what I identified was that the design they were approaching can be modified, and you can reduce a lot of dependencies. So in a sense, rather than doing dependency inversion or dependency injection, I would rather do dependency elimination. right after this conference, I blogged about it. If you're interested, just Google for knock out before you mock out, and you will see this blog entry that I wrote, where I recommend that we, as much as possible, remove dependencies or rework dependencies to a different level so we don't really take the burden of mocking as much as we can. So the moral of the story is mock only as an exception than a norm. Keep mocks very, very minimum. Mock only code you directly depend on. Mock only code that's slow or unpredictable or hard to set up or makes testing really hard. And by removing the mocking dependency, reduce the dependency, you can reduce the mock. And of course, you decouple the code by applying dependency inversion, and you can do mocks as well by really making the test very, very thin and sliced up. You can reduce the burden you have on creating the mock when you do have to create the mock. Never create a full-blown mock that represents a class and grow a mock into complexity. So keep it extremely minimum. Mock is really useful, but think about this like a pill. A pill is useful, but you don't want to rely on pills for every day. You want to, as much as possible, try to live a healthy life without a pill. Think of a mock like a medicine. Medicines are good, mocks are good, but you don't want to have them too much. So the point really is use it very selectively and don't overuse it. And use it to really speed up the test, and don't use it for making the test overly complex or hard to maintain or become brittle. So use it very cautiously, but mocks are a wonderful tool if we use it properly. So think about the practices we talked about, the example we created, and go ahead and create some examples. Practice on your own and play with it. There's no better way to learn about TDD and mocking than trying it out. So go on and experiment and have fun with it.